What's happening, Unprofessional Engineering listeners? This episode is sponsored by Xometry. Xometry makes quality parts fast with instant pricing from your 3D files. Check them out at xometry.com. That's Xometry.com. Make sure to use the promo code UNPRO25 to get $25 off your next purchase through April 30th.
Hello and welcome to Unprofessional Engineering. My name is James.
You got Luke.
Luke, we're joined once again by a special guest, Greg Paulson of Xometry, the Director of Application Engineering there. Greg, thanks a lot for joining us again.
I'm super excited to be here. Thanks, guys.
So before we get into everything we're talking about, which is going to be focusing on 3D printing this time, I saw that Xometry has a bunch of trusted companies listed on the webpage, like BMW, NASA, GE, a few others. I can only assume that the Unprofessional Engineering logo is going to be posted up on that webpage alongside of those any day now, right?
Sure. Absolutely.
Okay. Yeah. Well, we'll try and hold you to that. Okay.
I will say that, so it's obviously like NASA, government agencies, you have US Army up there as well.
Mm-hmm.
But BMW, Bosch, GE, they've all been Xometry customers for us, doing manufacturing on demand for them. And then they actually moved into investing in Xometry too. So It's been very interesting because they're like, I'm not just a member, I'm also a customer.
Yeah. I love it.
So I can't speak for James, but I am willing to invest all of our podcast money into Xometry. So just whatever that amount is, we will invest all.
I love it. To get our name up on the webpage.
Oh, goodness.
All right. For those of you who've missed it last time, you should go check out our last episode where we talked with Greg about Xometry. But Greg, could you give us a quick overview for those who missed that episode on what Xometry does?
Absolutely, will do. And I'm going to take a different lean right now because we have engineers, we have people listening to this who are in the professional engineering side or unprofessional engineering side. And Xometry shows you how much you can do with a 3D CAD model. So we are a manufacturing as a service company. And with a 3D CAD model, you can upload it to Xometry.com. So it's Xometry.com. And in seconds, you'll get a price for this part. And we actually have 11 manufacturing technologies that will instantly show pricing and lead time just based off that 3D geometry alone. So whether it's CNC machining, sheet metal, urethane casting, injection mold, or 7 of our 3D printing portfolios that we have. So we have 7 unique types of 3D printing. You get that instant price and lead time. And then from there, you can go and configure to spec. So if you do have a drawing that you want to attach, boom, attach your drawing, add tapped holes, threads, surface finishes. You could do all that on our website as well. So this is a very, very efficient way to get parts quoted and ordered and fulfilled all in one place with multiple technologies. So our goal is to be a one-stop shop for manufacturing.
So I'm going to go off script already, so I apologize.
Great, let's roll.
We're the worst.
I know I am. I'm sorry. So a couple questions come to mind when you say this. Mm-hmm. So you said there's 11 technologies. You're also looking for manufacturability of these parts as they're coming through, I assume, correct?
Yeah, so we definitely look at certain limitations. First off, for additive, a lot of times there may be some size limitations depending on processes. We have some processes that can print up to 3 feet. We have some processes that can really, only go up to 6 inches on them. So there's these different things, as well as some basic manufacturability feedback about the part, and as well as we have expert engineering teams on staff who day to day are working more as consultants, working through projects. So I know a lot of times if you're designing a CNC machine part or a sheet metal part, you kind of don't accidentally design one of those parts. You already know what you're doing. You kind of know the alloy and the different things. So it's more about assigning those specifications to the site. But with plastics, a lot of that is a help you choose environment. And we have experts on hand to help take a look at it, as well as give you some guided feedback. Actually, just this morning, I was talking with my colleague. Someone was building a SLA part. So this is kind of a resin 3D printing method. And they had microchannels in it. So it's a microfluidics device. And, some of the feedback we were looking at was, although the channels themselves, they were evenly spaced out, like we wanted to make sure that they could be cleared out after curing the resin, so we could actually cure and have hollow channels on the inside. So our team, our DFM team, will go and kind of give that feedback to the customers. It's pretty exciting and day to day for us.
DFM,
Designed for manufacturability.
I knew that. I
liked how you teed that up.
I was just playing along. I think I knew that.
Yeah.
So you had mentioned that you can upload this component to the website. Is that something that I need to like log in and have an account for? Is this something that you do without a login or a sign in, and then the model, the business model is once we see the value, then we engage with you? So what's the process as someone that would be uploading a model?
So it's completely free to use. So you can go and upload your model, and we accept most major file types. So if you have your native, so if you're running Autodesk products, you could upload your native files, or if you're running SolidWorks, you upload a solid part, or if you're uploading just a step file, that's kind of like the PDF of 3D files, where it's just generally accepted everywhere. But once you upload that, if you are a new user, it'll prompt you to give some basic information. Because we need to make sure those files are secured to you and only accessible by you. So we at least need a platform like your email address to start. Gotcha. And then you can finish your registration from there. So you're not just uploading into like a nebula there, you're starting to secure your work, because we work on a lot of, usually a lot of our customers come from like that aerospace or defense industry. And we have a certain level of security assurance that we need to qualify for them as well.
Gotcha.
Or exceed. Yes.
If I did anything technical in life still, like back when I did tech support for software stuffs, I would have loved to have known the line, step is like the PDF of CAD. I mean, what a great description. That just makes me happy. The nerd in me is very happy right now.
I think the reason why they make me talk in front of the mic here is because I spent I think I'm on 12 years now doing the consultative conversation and turning everything into some sort of descriptor. Like when we talk about Shore A values, which is like the squishiness of rubber, I'll say like Shore A20 is like pressing into chewing gum, and Shore A95 is like pressing into your car tire, and Shore A50 is like a rubber band. So
they say that if you're really an expert in your field, you're able to explain things in extremely simple ways for anyone to understand. So I feel like if you're not already there, you're well on your way.
All right.
So this episode, we're going to focus primarily on 3D printing. Like you said, you have 11 different, manufacturing capabilities that you have access to at Xometry, but we're going to focus in on 3D printing for this episode. It's something we think a lot of our listeners are interested in for a couple of different reasons. It could be maybe they're a maker and they do this stuff at home, or to your point, a lot of the folks listening, these are engineers and designers, working all day long inside of a CAD tool. And when you think of that particular person, if you had to say how 3D printing fits into, that traditional manufacturing process, where it doesn't exist right now, maybe they're a company that hasn't adopted it, they haven't looked into it, what would you say some of those benefits are and how that fits in?
Yeah, absolutely. So, we really talk about that in prototype, bridge production, and then end use parts. And all those things can mesh within each other, because one material process can be all of those at once. But sometimes you transition or graduate to different processes. But by and far, 3D printing has been, for the last decade plus, the king of rapid prototyping. In fact, they used to be called RP machines, for rapid prototyping machines. So the term, additive manufacturing and even 3D printing really didn't come along until probably, around 2008 or so. Like 3D printing started getting picked up by the media. So before then, everybody was saying, "Oh, I'm running an RP machine," and that was my professional additive manufacturing platform I had. But this is why it's so good at prototyping. I like to think 3D printing is kind of like the transition from analog cameras to digital cameras, where with analog, what I was when I was loading that film, if I loaded it poorly, I had 24 shots. If I loaded it really well, I got 28 shots out of it. But I was really mindful of when I took those shots. And I didn't always get them right anyways, even when I was mindful about it. Where we have a digital camera, you're just shooting all day long because memory is practically free. And with additive manufacturing, the same analog comes around where I can now do rapid iterations at a very cheap price without high investment of tooling or time. Like a lot of times getting parts delivered within like 2 business days. And I'm able to take snapshots of a project in development, get a tangible reality, and be able to put it in an assembly or give it to a customer or work on it for kind of a review and do a revision change and work through the next iteration. Ultimately, usually getting, just like digital cameras, I get a better picture a lot of times because I'm able to choose the one that's the best and move forward with that. And just like that in additive manufacturing and prototyping, I'm able to get a better end use product, regardless of the process that I'll eventually be made out of by using this method. So I could do that multiple iteration approach.
So I need to pause here for a moment. Now, I don't know how old you are, Greg, but your picture makes it seem like you're pretty young. Do you actually remember loading film into a camera?
Yeah. I still have.
I never have.
Are you sure you're not a hipster and like you went to like a vintage store and bought an old camera?
One day, I aspire to be a hipster, but I'm way too square.
Okay.
I love
I'm
it.
like the squarest person you've ever met in your life in reality.
Nice.
So you mentioned like prototyping, and I think that's what a lot of people think of, but it's not just prototyping, right? I mean, my understanding is, depending on the technology that you choose, and we'll talk about a couple of those in a little bit, but depending on the technology, once you've narrowed down through rapid prototyping with 3D printing, you can actually make, production quality, I can put this into my system and it's going to have a duty cycle and it's going to run for a month, a year, whatever it happens to be for that particular component. Can you talk about that aspect a little bit?
Yeah, absolutely. And actually, I got a great example from this is a client years ago. He did this project, and he never used additive manufacturing before, but it was working on a device that basically was part of like when you walk into CVS or something, the door opens and closes. Well, there's a little function handle kind of holding that door and opening and closing and swinging shut. And he decided to try out SLS 3D printing for this particular mechanism. So the mechanism that actually slides open and shuts and has like a little bit of a kind of a belt gear on the inside. And he printed this in nylon. And he sends me an email, like out of the blue, a year plus later. He's like, Greg, this has gone through 1.5 million cycles.
and it was prototype.
And it was like, I mean, it was like one of the things about this is with 3D printing, you can get end use durable materials.
Yeah.
And your product size can be 1 or 5. Like you can all of a sudden hit a very limited market or a very custom market without a high expense in manufacturing. So you could oftentimes get the kind of the best of both worlds, because what's matured in 3D printing has been those materials, the knowledge behind those. So a lot of this knowledge has been usually in the shroud, and that's where I lived a lot of times, that tribal knowledge of, I know how it works because I failed 1,000 times on the processes. Right. So to tell you about that, but now we have more content, more resources. So even people getting new into industry can say, you know what, I can just print this and use it right away. And that's very exciting. And so that works really well for processes that 3D print in thermoplastics. So like your injection mold materials, those are thermoplastics because you add heat, thermo, and they plasticize, they liquefy, and will go out. And that's something that you can do with selective laser sintering and multi-jet fusion and FDM, where I'm adding heat and I'm creating a melt, and I'm creating a part from those melt bonds as a building up. There's some materials that are less resilient. So a lot of these photopolymers, like SLA and polyjet, and I'm getting a little ahead of there, they're really good for accurate prototypes, but they tend to brittle because they UV cure over time. So they may not be as end use, but they still have that snapshot power to them. And then of course you could print in metals, so metal is metal. I mean, you can't argue with it. It's stainless steel. And so even though you're just making one of it, that thing's going to last, forever, because it is, such a robust, durable material.
So I have an offer for you.
Mhm.
I have 4 rolls of PLA sitting on my desk right now for my old printer. These are about 4 years old. I don't know. I'll sell them to you. I'm not sure what they're worth each, but I stack my monitors up on them because I haven't touched the PLA in a long time. So
they're so dusty right now. It's
so
disgusting.
dusty.
So let's talk about some of the excuse me, some of the common FAQs that we get at Xometry. So Xometry, we are running industrial additive manufacturing, and there definitely is a difference between what you're running, so a desktop 3D printer versus an industrial 3D printer. And we get a question a lot, like, do you have PLA? It's because someone is running PLA and they're used to it and it's their material. However, for a lot of those who've run PLA, you also are aware that PLA is chosen for desktop 3D printers because it has kind of a low fume. It it doesn't get super stinky when you're heating it up and running it in an open office environment. It also has a lower melt temperature to it, so it has ease of printing for a consumer use, but on a practical end use component, PLA is actually not a common material used. Like
Really?
it's not used as frequently. So usually it's replaced by like ABS or ASA, or other thermoplastic materials that have a little bit more of a robust nature to them. So when I do industrial 3D printing, these printers, they don't run PLA. They're usually running something more commoditized, like ABS or ASA, as like the lower end material, which is still way better than PLA, or nylon, like I mentioned before, which is a really cheap material to run, yet very robust because I could just do this freeform design around it. Is still way better than PLA for a lot of properties. So there's this difference because we could run more industrial materials because we have a much more controlled environment in these professional printers. And just as for like order of magnitude cost, like you could buy a desktop printer, right, for hundreds of dollars, where a lot of these professional platforms that are running are in the hundreds of thousands of dollars on a platform. So it's a very, very different investment.
Probably won't be
You're
buying
investing
one.
in a factory. Yeah.
Yeah, basically investing in a factory. I want to continue going down this path of the desktop versus industrial printer, as well as materials. But before we do that, let's take a quick break for a word from our sponsor.
Let me guess, no sponsor because, as usual, you are the worst.
Actually, smart guy, this episode is sponsored by Xometry.
What?
I know, mind's blown.
If you're looking for on-demand manufacturing with massive network capacity for CNC machining, 3D printing, injection molding, or any kind of rapid manufacturing, make sure you check out Xometry.com.
And while you're there, check out the new complete guide to 3D printing, which can be found on the resources tab of their homepage.
Better yet, make sure you use the discount code UNPRO25 to get $25 off your next purchase, James, through April 30th.
That is so much money.
It is.
And one more time, that's Xometry.com. Xometry.com. All right, so we were just talking about how desktop printing and industrial printing are a little bit different. Have you seen somebody that's gone from, let's say, working with their Boxy or their printer bot or their maker bot or any other name drop that I'm going to put out there, and successfully moving into industrial printing, meaning that they reach out to you and start taking advantage of your technology because of what they've learned from their desktop printing?
So 100%. In fact, actually, many of Xometry's customers, actually most of our customers, have some form of manufacturing. And sometimes it is just a printer. They're used to having a printer. And some of it is their manufacturing facilities themselves, but they don't do everything. So we do a lot of everything. So they're using us to supplement either from a capacity standpoint, because we have significant parallel capacity through Xometry. So we can run not just, we have one machine and we're sterilized, but we can have a manufacturing partner network to run thousands of jobs in parallel with each other. And they're using that capacity. They're using our variety of materials available to go through. But I love when they have their own manufacturing because they already have an intuition about how to design for 3D printing. They have intuition about things like support structures for a lot of these platform bed processes like FDM, where you have that filament spool and it's kind of zigzaggy back and forth. And also about things like minimum wall thicknesses, distance from holes to edges. This intuition is kind of built up because they're already doing it in-house anyways. So yeah, it's a great advantage.
Interesting. Now, quick hypothetical for you here. Hypothetically speaking, say there's someone out there who's like, I don't know, playing Dungeons and Dragons, and they want to have their little miniature figures printed out, but they don't have a nice printer at home, but they only need like one or two of them. Is that something that Xometry is capable of and happy to do? Is it cost effective at all for the person to reach out that way? Or is this more of like, you need to be printing 10,000 parts to make it happen?
Oh, there's no minimum order quantity. That's one of the things I love about 3D printing platforms is I do a digital setup, right? So I'm on my different platforms, they all have some sort of build setup programming where I'm taking that 3D CAD model, I'm using it to set up digitally, and they can have neighbors to them. So I could just print, one of this piece and 5 of these pieces and have them all on the same platform. Or, for example, some of those processes like the nylon process I'm talking about, we're usually building 30 to 300 pieces per build in there. So there's a lot of parallel run. And that could be, unique pieces or all the same pieces. The printer doesn't care. It's just, it's just going to interpret how that 3D model is set up and do its darndest to try to replicate that in reality. And so you can definitely enter with quantity one. If I'm doing a figurine, I'm going to be looking at a couple trade-offs, right? So a lot of times you're looking for something that maybe I can do some post-editing to, like a paint or sanding down, or getting some fine details. There are processes like those resin processes, stereolithography, which are very good at getting that high detail resolution and smoother surface finish. But you may also go on another approach where it's like, I just want to build a bulk of these, in cheap and kind of get them to smooth enough, like think like an eggshell type texture. And things like HP multi-jet fusion can print parts very cheap, especially small parts where it's going to be like a couple bucks, to make those parts. So it becomes very economical for you to build an entire set of different components all in one quote and press go.
So you mentioned a couple of different technologies there, lots of acronyms. But so what kind of, or I think you said there were 7 or so. So what are the specific printing options that you have available to customers?
Yeah. So I'm going to group them a little bit because I think I was telling you guys earlier, I mean, we could just talk all day on every single one of these and go very deep into each subject. From a most commoditized standpoint, I've already mentioned this a lot, nylon. Nylon tends to print very easily in what's called powder bed fusion platform. So that's where there is the material they're using as a raw material is powder. It looks like a flour, but it's actually nylon. And you are selectively melting cross profiles of it, almost like cross sections of your part there. Well, exactly like cross sections of your part. And then you're putting the next layer on top and you're melting down the next layer on top and continuing. What's nice about these platforms is that you're building parts without the need of the sacrificial support structure, which you see in a lot of 3D printers. So that's those little kind of vertical tines that are holding overhangs and other things. In powder bed fusion, like this powder bed platform, you're actually building without that because the parts are kind of suspended in unused powder. So think about taking a golf ball and just sticking it into flour, letting go. It's not sinking, it's not floating, it's just there. That's how these parts come out when they're done building. So I'm actually digging these parts out. And we have 2 types of powder bed processes that act that way. So HP multi-jet fusion, which is a Hewlett-Packard brand. That's why it's HP particular. And that does a different way of heating the material to melt, different than SLS, so selective laser sintering, which is also doing the same thing where it's melting material but using a laser. So HP will use kind of a heat bar and an ink to essentially absorb heat more where it's inked, that cross section, creating a melt point only in the ink section, and everything else remains unmelted, where SLS will use a laser to do the same thing. So you get a very similar result mechanically, but they have a little bit of different advantages between each one. depending on the production of the parts and the size of the parts that you're making. So that's powder bed. That's two. The other big classification that you see a lot is that fused deposition. So again, talking about that spool of filament being melted down, we call that fused deposition modeling, or FDM, on the professional world. Most of what we're running, actually all of what we're running for large professional projects, is the Stratasys Fortis FDM machines. And they have build areas. The smaller machines are 16 by 14 by 16 inch build areas, and the larger machines are 24 by 36 by 36. And here's the difference with these machines versus those powder machines. Those powder machines, I have a choice of basically nylon, nylon 12, nylon 11, nylon glass fill. And we also have a thermoplastic urethane, a TPU, that's kind of rubbery, that's available, but you're very limited on material choices. When I talk about FDM, because I'm able to change out that spool of material, I have a much more boutique printing option. So I could print, between ABS and ASA, I think I have like 20 different colors or different options through that. I have polycarbonates, I have PC ABS blends, I have high temperature and high chemical resistant materials like Ultim to print. So I'm able to set up a machine just for your build and build those parts the way that you want it with FDM, because I have that boutique manufacturing where I'm able to just kind of load in yellow ASA or whatever material it is and run my yellow parts and then switch it out for the next run of parts on those platforms. So those are like, between those and the powder bed, those are like the commodity ones where it's usually you're going to find the cheapest materials and a very high throughput, like a very high amount of parts being made on those platforms.
You weren't lying about how long you can talk about these different.
Yeah, I know. I'm trying to keep it brief. I'm trying to keep it differentiated and brief. And I don't, it's a little tough because I'll go into like the next group, and I have one more group after this, but the next group is these photopolymers. So another thing that you could do is, if you guys ever had a dental filling, you may have had someone put some goop across your teeth and then shined a UV light on it, and that UV hardened into a durable surface. Well, that's what stereolithography and a lot of these digital light projection methods are doing. Is they're taking a resin that is liquid in its base, but will harden when exposed to UV light. And stereolithography typically uses a UV laser to harden cross sections of the part and create a rigid part afterwards. Or a DLP method may use a projector, again, a UV projector, doing a full cross section at a time, kind of like shining a video up on this liquid resin. Either way, what's cool about that is those parts tend to have a smoother surface finish because they're coming out of a liquid material. And they're really good for parts that have more kind of a plastically smooth feel from a get-go, as well as parts where you may want to do some post-processing and kind of polish up to either a shine or to clarity. You could do that with SLA really well. Like, you take a part that actually will print in a clear resin. The base look of it may look a little bit frosted because that's as it comes out of the printer, like any defect on the outside of the material will just kind of show that frosted look. Just think about frosting glass, for example. You hit it with a bead blast and all of a sudden it looks frosted there, even though the glass is clear. Same thing happens on these prints, but if you polish it out, if you buff it out, you'll get some very nice clarity through those parts. So that's where SLA is really strong, is that detail and surface versus SLS and multi-jet fusion and FDM, where it's more about that low cost, high throughput.
So before you do the last method, I have a question. So have you seen those as seen on TV UV pens, where it's like it can fix a coffee cup and then you put this little UV light on it? Is that is that essentially the same thing? Because it's a little UV light and some kind of chemical. Granted, it's not nearly the accuracy I'm sure that you guys are doing, but is that essentially what that is?
Yeah, so I'm actually pretty sure that was invented by a dentist who's just doing some fillings. They're like, I wonder if I could also fix my coffee mug, and they did that. But the technology is essentially identical. The control is different, right? So I have my machines are controlling to do cross sections. It's not my shaky hand doing it. Okay. But yeah, you're filling that material.
Gotcha.
Something to note, though, is, this UV cure is really nice to make these parts look uniform, look very pretty. The UV cure also has a detriment over time a lot of times, because even my overhead fluorescence may be curing my material forever as it's exposed out to the outside. So I may have property changes. But there are processes like carbon DLS, which is very similar to SLA, and it's almost like an innovation of SLA in a lot of ways, where they've taken advantage of better material science to almost do a post cure. So activating dormant properties in the material after it cures to its 3D printed shape. And then those dormant properties actually enhance the overall parts to act more like a urethane, which is a much more end-use ruggedized material. So there's some really cool innovations that are going on, very traditional processes. I know we talked a little bit before the show, but SLA was invented in 1984. I mean, this,
I was 2.
Yeah.
I was 2. I thought it came out like 5 years ago. Oh my goodness.
Yeah, so it's been around a bit.
So speaking of how long it's been around, give us a quick take on where you think 3D printing is going to be in, say, 5 years, and then maybe what you think it's going to look like in 20 years from now.
All right. Yeah. So 5 years. Well, we talked about these powder beds. We talk about stereolithography. Like you're seeing a lot of changes in the materials being processed. So better material science. I want to say back in the day, but a lot of times the first materials that you see, like that nylon 12, for example, it just happened to be available. Nylon 12 is used for powder coating. So in the late 80s, when SLS was being invented, they just happened to be able to buy in bulk this material that's used for essentially a painting process and try to melt it and figure out SLS. And it just happens to have very unique properties that make it great for this type of process, and it has this legacy. But now I'm seeing more and more materials specifically designed for the process to work really well with 3D printing and have these properties. So instead of saying, hey, I like injection molding ABS, so therefore I must 3D print in ABS, maybe there's a material compound that is just absolutely fantastic for 3D printing alone that can give me these really great properties and behaviors analogous to something I may be used to in a different method. And I'm seeing more and more of these unique material combinations coming out, including what I mentioned with that carbon DLS, where it has that post-activation. I'm also looking at post-processing. Automation is a very big thing that's coming out. It's really coming out now, but in 5 years, I think it will be much more common. One of the biggest complaints about 3D printed parts is that surface finish, because we're used to injection mold parts. We're used to cut parts where when you cut something, it has a nice smooth finish to it. And injection molds are essentially, cut cavities that are filled with plastic. So the plastic has that finish of that cut cavity to it. But with 3D printed parts, you're kind of getting that finish of that raw material. So if I use a powder bed, so if I use, for example, like I'm doing direct metal laser sintering, which is a powder-based process where I'm melting that metal selectively, I have a powdery look to the outside of the part. If I cut into it, it looks completely smooth. It looks like, billet block material. But the outside always looks more matte, more powdery. FDM, it's that zigzagging of a filament. So the outside of the part looks more like a filament, zigzag than a nice smooth surface. I'm seeing post-processing options coming out now that take away the hand sanding of that or these other options and make it more scalable and gives a smoother surface finish to the parts overall. So that's been exciting for me to review. I think a lot of these technologies are actually very well established, and a lot of the innovations coming in that software and the material science side of it. And there's going to be minor innovations on the actual technology platform. And some of that's going to be disruptive. Some of it's not. It's just going to be incremental. But I really see a lot of this with how can software and how can better materials use these platforms to just make them absolutely awesome for, I think a good metric for me is when the job that when I create quantity one is just as good as the end use as if I'm going to make 10,000 plus of these in production. Like, can my prototyping method also be my production method and keep it at a low cost? That's a win for me.
Quick question. Do you see, it seems like a lot of the, I'll say innovation for lack of a better word, is just these things getting bigger. The the machines, the print bed or area or envelope or whatever you want to call it, is there like in your mind, potentially, is there like a limit to that where it doesn't make sense to go bigger? Like I'm thinking there's a company right down the road for me, and they make these enormous rollers for like steel mills, right? And these things are like half the length of a tractor trailer. They're like, 25 feet long. They're, a foot and a half in diameter. You could potentially, if you had a printer big enough, 3D print that and then do some post-process machining for tolerances and stuff like that. Is that not going to happen? Do you think that's like a big step, or do you think it's always going to be this kind of, bread box kind of car size limitation to 3D printing?
That's a really good question. I'm also excited to see what comes out of that. Here's the thing. It's like, so if I'm doing a filament spool base design, I'm usually extruding one filament at a time, right? Or one filament thickness, and going up very small increments. So if I have a really big part, it's taking me forever because it's basically drawing a full piece of artwork with one pen and just kind of keeping it attached to to your palette the entire time. And you're doing a lot of drawing, and it takes a lot of time. So you can either make a quicker deposit, so I move my pen quicker, or make a thicker, feature. So instead go to a stubby marker or something and make it, more coarse, and increase my layer sizes. But there's a lot of challenges in going big with additive technologies and keeping detail there. I think those approaches are going to be more hybrid. So if you look up something called Big Area Additive Manufacturing, so BAAM, you'll see this technology is kind of extrude almost like an inch thick, cross layer to this material it's actually a quick curing material. So it's different than a thermoplastic, but it'll cure up really quickly. But what they have on these machines is also a post CNC mill that'll go and smooth out the surface. So it's like, hey, I know I'm building a net shape here. I know that I'm using my additive growth to build something that is more coarse than the final product. But I have mechanisms to make it smoother and integrate with my final product better. So I think that's where we're seeing a lot of those innovations is they need some help from their friends in the manufacturing world. So a CNC mill on these, or some sort of post-processing, or maybe they're just a forming tool for a larger process. For example, thermoforming is a great way to make large plastic parts or large composite parts. Making that tool is sometimes the most time-consuming part of that. So you can make a tool out of a bunch of 3D prints and have one continuous piece after using like a thermoform or composite process.
All right, so we're running out of time here, but I did have one more thing that I wanted to mention here, and that is that Xometry also has kind of like a partnership opportunity for manufacturers out there, where you can actually head over to Xometry.com and sign up to become a partner. Could you give us like a quick overview of what that is and how it works?
Yeah, so Xometry, the power of our business really comes around this digital chain from upload, getting an instant price, pressing order. On the fulfillment side, Xometry is always your sword and shield. We are the person that you're buying the parts from, and we have fulfillment done through our manufacturing partner network. So as a customer, think of it almost like a Uber or Lyft, where you're saying, hey, I need this, I need a ride to the airport, and you get a price instantly, and you press go, and it's accept. And then, you get your ride to the airport, and everything's, great. With our manufacturing partner network, we do have manufacturers that we have vetted and onboarded in all these different experiences and technologies. And some of these are, well-established manufacturing businesses. Actually, a lot of them are, with decades of experience in their field. So like sheet metal or CNC machining or additive manufacturing. And we're able to pair the work with the manufacturing partners so they're able to take work on demand that fits them the best. So we actually have AI and machine learning that's looking at the type of work that's being ordered and saying, hey, these partners on our network are going to be the best in the world capable of doing this work. And it'll give those partners an offer where they could just take it. And for them, it's this benefit of being able to take work without having to go search out, find the clients, do all this marketing, have a whole sales team around. They're just able to focus on making really great parts, which is, value add for your job there. So it's a really great relationship that we have with this partner network of over 4,000 manufacturers. And, most of that is our domestic manufacturing partner base, We also have global entities, including we have a European branch, Xometry Europe. So yeah, we're growing.
That's awesome. Greg, this was a pleasure as always. I really appreciate you taking the time to jump on with us and, really get into details about the 3D printing world and where things are headed.
Yeah, it's always a pleasure to be here. And like I said, I know I could talk lectures. So anytime you guys want to ask a question about 3D printing, I'm always happy to talk. And also for listeners, if you have questions, feel free to shoot me a message. I'm on LinkedIn, or I'm Xometry Greg on Twitter. And of course, Xometry's website is a great resource. We do design guides, videos, and a lot of resources that are just there to help you learn. So even if you don't have something to order, you can actually go and check out the guides to better understand every one of our processes.
All right, for our listeners, hit Greg up on all the social medias. If you have any other questions, head over to Xometry.com to check out their webpage. You can actually find their new complete guide to 3D printing as well there, where if you go to Xometry.com, you can find it on the resources tab. And as we mentioned earlier, use the code UNPRO25 to get $25 off your Xometry purchase through April 30th. I hope you all enjoyed this, and until next time.
See ya.